Alright, yesterday we looked at solving by factoring and solving by taking square roots. Today we're going to look at solving by completing the square. Notice there's a lot less restrictions for completing the square. Completing the square for the most part can work on any problem as long as you know how to set it up. We've only looked at kind of the simpler ones so far, and so when you get to Algebra 2 you'll look at a little bit more advanced ones. In this one we want a equals 1, so we want ones that start with a plain x squared. Not ones that have a 3 or 4x squared. So when I say a equals 1, like there's a 1 in front of the x squared. And then this second term, b, we would like it to be an even number because we want to be able to think of numbers that add to 6, like 3 and 3, or numbers that add to 8, 4 and 4. It gets a little bit harder when you say what are two numbers that add to 7 that are the same, because now you're dealing with decimals, 3.5 and 3.5. So when I say b is an even number, it's definitely simplest if this term right here is even. And then it doesn't matter what this number is over here for us to complete the square because we're going to end up choosing our own number anyways. And so we're going to look at problems that kind of look like this today. And actually, why don't we start with doing this problem. We'll do one for completing the square, and then we'll kind of go from there. So here, if I said solve x squared plus 6x plus 1 equals 0, normally we'd want you to try to factor x that. And so we would go to set up our factor x. And we would say, are there numbers that multiply to 1 that add to 6? And if there was, that would be great. We would just put those numbers down, write it in factored form, and then just use our zero product property to solve it. But there are no numbers that multiply to 1 that add to 6, at least no whole numbers. And so when we look at this, instead of trying to find numbers that multiply to 1 to add to 6, we say, well, let's just ignore this one, and let's build our own factor x. Let's think of it our own way. So what are numbers that add up to 6? Well, we can figure that out. 3 plus 3 is 6, and it's going to be important that these numbers are the same so we can write it as a perfect square. But if these numbers are 3 and 3, then up here we would want to have a 9, because remember, we want numbers that add to the bottom and multiply to the top. If you look at this problem, though, there is no 9 in this problem. So what we'll do is we'll add in a 9. And then to make sure that we keep everything balanced or equal, we're going to add it to both sides. So I'm going to add the 9 here and add the 9 here. So that way this here, this x squared plus 6x plus 9, that trinomial becomes this x plus 3 times x plus 3 if we wrote those factors out. Well, instead of writing out x plus 3 times x plus 3, which we could, what we do instead is write that x plus 3 times itself as x plus 3 squared. So this pink part here turns into x plus 3 squared. Now this 1 over here we didn't like to begin with. This 1 was kind of part of the problem. So we're going to get rid of that 1 just by undoing it. Since it's a plus 1, the inverse is subtract 1. And again, whatever we do to one side, we have to do to the other. So this part here turns into x plus 3 squared because that's the factor x that made it work. The 1 cancels itself out, and then we have the equal sign, and we have 0 plus 9 minus 1, which is 8. At this point, we can just solve it like we did yesterday when we were solving square roots. We have a single x that we can get by itself by undoing everything that's kind of bothering it. So let's start with undoing the farthest thing away, which is the squared, by square rooting. So we're going to square root both sides. Square rooting that just kills off the squared, and it drops me out the x plus 3. And then remember that when we square root both sides, when we're solving quadratics, when we put the square root there, we expect two answers, a plus and a minus, of whatever that square root of 8 is. And so then we're just going to look at the square root of 8 and just grab our calculator and type in the square root of 8, which in this case is 2.828. And again, we'll do 2 decimal places. And so since this place is a 2, but this next number is an 8, we're going to round this up to a 3, so 2.83. So x plus 3 is equal to plus or minus 2.83. And then as we solve it, we'll solve just by undoing, by subtracting the 3, and just finishing it off by figuring out what the two x equals are. So this should look very similar to what we did yesterday, because everything from here is solving just by taking roots. Remember, there's two numbers we're subtracting 3 from, a positive 2.83 and a negative. So when you go to type it in, it's 2.83. Take away 3, that gives me one answer, and so that's one of my x values. And then my other answer just comes from the negative version of 2.83, subtract the 3, which gives me negative 5.83. So both of those are good answers. Both of those equations make this true. because again, when we have x squared equations, we expect two different answers. And so that's pretty much completing the square. The only thing that could happen that's a little different is you could have something that looked like this, where it said solve x squared plus 8x plus 2 equals 13. You could have some number on this side as well. It actually doesn't affect how you would do this problem, except for when you go to set up your factor x and you're trying to complete this square, you have 8 on the bottom, and so you say, well, what adds up to 8 is 4 and 4. If you need a 16 on the top, you're going to add the 16, but instead of adding it to 0 over here, you just add it to the number that's already there, and you're still going to subtract the 2 out. So the problem's done pretty much the same way if there's numbers over here. So don't be too concerned if it's not equal to 0. Notice this restriction doesn't have it has to be equal to 0, because we can complete the square, especially if this number is even and this is a 1, no matter what. And so we can always do that. Say what adds up to 8 is 4 and 4, as long as we have a 16. This then would turn into x plus 4 squared. The 2 we would subtract off, and then on this side we'd have 13 plus 16, which is 29, minus 2, which is 27. And then we would just solve from there. We would just solve the same exact way, trying to get x by itself. So the only reason we put example 2 here was because it wasn't equal to 0. But completing the square doesn't require you to be equal to 0. It just requires you to make this x squared plus 8x into a perfect square. We can do that by having a 16 added to it. From here, we're just going to square root both sides. I'll just finish it up for completeness sake. Just remembering that after I square root, I always have to have a plus minus. The square root of 27 is 5.19. Because this is a 6, I'm going to round this up. When I round the 9 up, it rounds this up. So this becomes 5.2. So even though I normally have 3 decimal places, this is going to be 5.20, which is the same as 5.2. So I'll just leave it like that. Now I'll subtract the 4 from both sides. And I get 5.2 minus 4, which is 1.2. And I get negative 5.2 minus 4, which is negative 9.2. That's completing the square. I'm sure there might be some questions on this, so if something doesn't make sense after you write it down and you're trying some on your own and you don't know exactly how to write this out or what to do next or something looks funny, don't be afraid to ask. I mean, that's certainly why we're here. And see you on the next vid.